Hi and welcome, I'm Jeff Hamilton. Welcome to the first part of a series of videos that we're going to do about the autochlor electrical systems, voltmeters, switches and relays, and I'm going to give you some practical tips on things that I've learned over the years to make my life just a little bit easier when I'm doing diagnostics in the field on service calls and preventive maintenance as well. Today's focus is just going to be pretty much on the voltmeter. I'll show you some of the settings that I use frequently and a couple of new ways that I've learned how to use it that allow me to unplug the machine or take the energy away from the machine so that when I'm working on it, I'm just that much safer and I just feel that much better about it when I'm doing it. So let's go. Before we get too far into this, what I wanted to do is just take a minute and give you a really simple description of how I have kind of figured out what electricity does in the buildings that we have. This is going to be a regular 3-prong outlet that you'll see in any receptacle in your home or in the accounts, most of the accounts that we have. And each of these prongs serves a unique purpose, and I'll just give you a little description of what's going on. There's a ground prong in our machine. It's green. And there's two slots that are different sizes. The larger of the two slots here is the white wire that we use in our machine. This is the neutral wire that doesn't have any voltage on it, and it really doubles up as another ground in electrical systems that we see. It is the return path, and it's necessary for the electrical to work in our machines. So when we plug a dishwasher in, if we don't have both plugs that work correctly, the machine won't run at all. And then the other slot on this side, this is what we call our red wire. It's the black wire in most of the power cords that we use. And it has a smaller space, and it's smaller so that if the machine is wired correctly, you can't plug it in backwards, meaning the white wires will never have power, and the power in the machine is always limited to the red wire, and it's where it's supposed to be. I'll talk more about this later. But before I do that, if you were to picture the electricity that's coming out of that smaller plug or going into the black or the red wire in our machine, I kind of learned it as like it's got some pressure available to do something for me. And what we're leaning on is the building's electrical pressure or voltage to provide us with power to make the motors turn and the chemicals go in and the lights to come on and the heaters to work. When that pressure is switched on in our toggle switch in the machine, it will be kind of allowed to go downstream to the next place that there's a switch. And if there's another switch like a timer switch or a prime switch, it will, once the switch is connected to the next wire downstream, it finally makes it to the end of the line and something like a drain solenoid will work or a heater will come on or turn off. And then at that device, whatever that load or that demand of power is, it has to have a return to go back to the building, and that's what the white wire is all about. If you have the red and the white wire plugged into, say, a light bulb or something like that, if you looked in a light bulb, there'd be a filament in the middle, and you just picture that the red wire is touching the bottom of the bulb, and then the white wire is connecting on the side where the screw part is when it goes down. And when it travels through that little filament, and it makes its way back through the white wire and then ultimately back to the building, there's energy that passes through there. And what it does is it goes through 60 times per second. It kind of reverses direction and it goes through. And we put a really thin wire between two big wires. Well, heat is generated, and that's how we make heat. And when we have a drain solenoid, we take that little thin wire and we stretch it real long, and we wrap it around a bunch of times, and then we connect the orange and the white wire like on a drain solenoid. And as that energy moves back and forth on that really long thin wire, there's friction involved. It's kind of hard for it to do its job in there on purpose. That's how we get stuff done. I'll describe how some of the loads work in a little bit more detail in later videos, but for us, the point today is that we have to have a good connection going in, and then we have to have the white or the neutral or the common wire, we call it, also connected or it won't work. This is an example of a voltmeter that you and I are going to see in the field. There's nothing fancy about it. It's a kind of a real basic clamp meter, they call it, a digital clamp multimeter, and that's what they're talking about the clamp, and I'll get back to that. This is a meter that I've had for quite a while in the system, and if I went down to Home Depot and bought an orange or green or yellow one, it would do exactly what we needed to do. We're not asking these things to do that much, and that's great because we don't need to be very sophisticated with a meter to be very effective with the tools that are available to us already. The meter has a couple of batteries in the back, and the way that a voltmeter works is it has a battery connection to this red wire right here, and at the end of that battery it goes to the red wire inside, and then if I were to grab the lead on the end of the meter, there's pressure available at the end of this lead right here because it's basically connected to the end of the battery on the positive terminal in this case. I have two batteries in here at 1.5 volts, so I have probably around 3 volts of direct current available to do some work here. Much like we've got 120 in our machine. When I touch this lead, like so, and I connect those two leads together, I'm creating a situation where the electricity can move then into the black wire, and it ends up back in the meter, and ultimately connects to the other end of the battery, or the negative terminal on these batteries in here. And when that happens, I can use that circuit, or that loop, to tell the meter to have a display that gives me some information about what I've got. I can use it to turn on a little beeper. What I'm going to do is just talk about some basic settings on the meter, and then I'm going to show you how that works for us. If I have a meter in my hand, let me give you some best practices first. If I'm using a voltmeter, I'm very likely to get distracted when I'm doing something. So I have developed some best practices that seem to be very effective at making sure that I'm using the meter in a way that will give me information that makes sense, and I don't miss a setting or something, and then I make some bad decisions based on bad information. The meter's off right now, and if I do something and it doesn't matter what I'm doing and I put the meter down for a minute or two, I've gotten in the habit of turning the meter to the off position and then back on. And the first setting on this meter is voltage, and I'm going to turn that on, and it has a display that's going to start bouncing around a little bit. Now this display is saying 0.0011 and kind of all over the place. If you picture you've got a bunch of wires running through the same conduit to go to different places at the end of the line, those wires have got a little bit of interference basically, and I may be seeing some numbers that don't quite make sense. If it's not 120 and it's more like 2 or 3 or 4 volts, that's really not current carrying voltage, and it can't get me. So just to feel a little bit safer, it helped me to understand that. On this meter, if I have the voltage setting, and then I can see right next to it, it's got a kind of a squiggly line. And that is an alternating current symbol. And what that means to us is that's the setting that we want to use when we're checking power on the household current devices that we are dealing with. So if we plug into a standard receptacle on the wall, that household current is represented by the alternating current symbol, and that represents that reversing rotation, the back and forth motion of that 60 cycles per second, where the power is kind of turning around and going back and forth. And that's how we get the work done in our buildings. The next setting is a horseshoe. It's the omega symbol, and it represents ohms. Ohms is the measurement of the difficulty that the electricity would have getting through something like a lamp filament or a heating coil. And I described that drain solenoid that has a long, thin wire that's wrapped around itself, and the other end of that wire is the white. That's difficult for electricity to get through on purpose. And we use that to create a magnet in a drain solenoid. In a motor, if you look at the back of a pump motor, it's got a bunch of copper windings, and those coils, those groups of magnets, are connected ultimately to two places, and that's where we put our power wire coming from the relay and then the white wire that goes back to the building. This resistance value and all of those things that are actually doing work is something that we can measure very accurately. I hardly ever do it. It's proven useful for me as I've gotten more knowledgeable about stuff over the years, but it's something that I really didn't need to know to be able to function for 95% of the stuff that I was being asked to do out there. But if I leave it on this setting, and this meter, and some meters are different, if I press the select button on this meter, when I touch the two leads together, it's going to beep. And a little hard to hear, but that beep for me is a yes or a no. If I have a continuous circuit in the meter, meaning the battery connected to the red, joined to the black, and then back through to the battery, it passes through a little beeper in there. And when that beeper goes off, what it's telling me is that I have a good connection. And that's important to me because I have a whole bunch of switches and relays, which are just switches, in our machines that I can use this for to see if there's a good connection from point A to point B through all of the switches that we have to get, basically permission from so that whatever we have is working. And this test is I use it 90% of the time for the work that I do now. It's a yes or no. Do I have a connection between the wire going to a switch, ultimately through the switch, and then down the line to be available for the next thing to work? And I'm going to use this quite a bit as we kind of putz around on the A6 behind me. This connection, this sound is good. If you have a switch and you're trying to figure out if it works or not, and you press the button or you push the toggle over, and you've got these leads on those two terminals, if it beeps, it means that it's working. And in 99 times out of 100 or more, if I have that happening here with the battery pressure that's available, it's going to do the same exact thing that it's going to do if I plug it into the wall, which is great because I don't have to work on the machine when it's plugged in or turned on. I can do a lot of this stuff with it unplugged. Real briefly, the next few settings, this is an A, and in this case it has that alternating current symbol next to it. The A is for amperage, and amperage is a measurement of the amount of work that something's doing. If I think about our machine and I have a little red light bulb that's on during the cycle when it runs, or I've got a chemical pump motor that's turning around, if I put that into kind of perspective with the amount of work that the pump motor is doing to wash and pump water through a machine, it just seems like the wash pump is doing a lot more work. And it's true. Our pump motor draws between 10, 11, 12 amps at 120 volts, which is what we use. The light bulb is a fraction of an amp at most, a tenth of an amp. The chemical pump motor is probably about a half an amp, 0.6, 0.7. It's quite a bit less than that. When I measure amperage, much like a magnet or that resistance or that interference that I was talking about with the wires that are inside of conduits inside the buildings, this clamp is when I would use that for amperage. At the end of these little clamps, there's a little metal contact in there. And if I clamp those two together so that it makes a loop, a circuit, then the meter can kind of see the amount of energy that's going through this horseshoe or this clamp here. And when it reads the amount of energy going through, it's going to give me some number. And in our case, it's going to give me the amount of amperage that something is using. And the next setting that I want to show you on this, the only other one that you might see on your meter, is called NCV. And NCV stands for non-contact voltage. That's the setting that will show you if you have electricity. I've got a little power cord over here. If I put this near the power cord, it beeps and there's a little red light that flashes. And it's exactly like those little pen meters. They call them Widowmakers. You put it in your pocket, and you can hold it next to an electrical cord or electrical circuit, and if you're lucky and the circuit is on, it'll light up and it'll beep. And if you're unlucky, it won't work right when you think it should. And the problem with those, and the problem with this setting, is that if I use it for anything other than telling me that yes, there is power on, I'm asking for trouble. I never want to trust this on the NCV to tell me that the power is off. That's not a good way to do business, because sooner or later what will happen for me is I'm going to have a meter in my hands, and I'm not going to remember to set it back to the right setting, or I'm going to get a faulty reading from the cord, and the power still be on. Now, before I go, I want to give you a little preview of what's coming with the meter. The first thing we're going to do in the next video is we're going to walk through what it looks like to have a meter in your hands and a machine that's live, and figure out where to check for voltage, and then how to feel real confident that the voltage has been turned off and that you're safe to go ahead with stuff. I'll walk you through that, and then in the following video we're going to walk through some switches, but I'll just kind of give you a little sneak peek of what's coming. We've got a standard on and off toggle switch here, and this is, we call it 2-pole toggle switch. Means that it has the ability to switch off more than one set of wires. This is what we see in our on and off switches on our machines. Most of the time you're going to see it with a red and a white wire on both sides. I've got my meter. I'm going to turn it off and back on to continuity. And when I say continuity, I mean, does it beep or doesn't it? And then this meter requires that I hit the select button once. I'm going to set my meter down so I don't have to handle it. I'm going to touch the two leads of the meter together, and it should beep. There we go. And then I've got a couple of alligator clips. The ones that I've seen out there kind of come as an accessory, and they're easy to lose, but they're real cheap on Amazon. They're nice to have for different things. I'm going to take one of the leads and I'm going to clip it on one terminal. If I didn't know what was going on with the switch at all, I'm just going to clip it on another one just for fun and see what happens. And then I'll flip the switch and see if anything happens. And doesn't seem like it. So I'll move one over to another terminal. Clip it on. And now I'll turn the switch back on. And it beeps. And it turns off. Well, that's cool. That means that if I have this and this terminal in this position, that if I have power available on one of those terminals and I turn it on, it's going to be available at the other terminal, and therefore at the end of whatever wire goes from that lead. Things that look like this and this and this. And I can do that same test with a continuity tester, and it's going to give me some useful information so that even if I've never seen something before, I can kind of figure out what the function of these things are. And once I kind of started to figure that relationship out, is that I have, and I think in terms of, it helps me to think in terms of what's upstream or on the coming in, and then what's the downstream side of stuff. And if I have power that's available on a switch and I turn it on, and it's allowing energy to go downstream of that into the wire, then I just kind of trace the wire down and figure out where does it go, what's it connected to, and if it doesn't look familiar, then I can snoop around with my voltmeter set to continuity, and I kind of figure out what the current wiring function is. And the value of that for me is that I get, number one, I work way safer when I know that the power's off. It's way easier to focus, and I'm not going to get hurt. So it's like a win-win-win. Anyway, thanks for joining me. If you have any questions, you can hit me up via Teams. It's Jeff Hamilton, J Hamilton at AutoCore, and I'm always available to help you guys out. Thanks.